Alright? Makes a bit more sense having it on the one screen here. Did I not tell you I speak Scottish? Not really, but I just love that, imitating that accent. What can I say? Right, diagram. This is the 19th century method of working out the speed of light. They reckon it's one of the popular ones, all right? But it is said that in the 1700s and 1800s, they used mirrors and naked flames. Naked flames, because that's all they had. Candles. In fact, one of these beams travelled 16 kilometres. There was no power, there was no light, there wasn't any of these. Just oil lanterns and the light of the sun. 16 kilometres this one beam went. A couple of mirrors. Landed on the tooth of a rotating wheel, they say. Seriously? What we'll notice first of all right here is there is not one single number. There's no distance between that and that, or that and that, or that and that, is there? No measurements. What kind of lens was that? It just says lens. Right, let's just read it straight off. The method it starts off with, because obviously I'm not going to write all of it, so just the working out bit. So very first thing it was measuring the speed of light. The classical 19th century method of measuring the speed of light is illustrated in figure 1. This method depends on the relative position, so that's how it starts, okay? This method depends on the relative position of points E and E1, all right? Well, you, the people that have written the book, what is the distance between E and E1? That would have been a little bit of a help, I always think, all right? This is how it starts. The position of E is measured with mirror R, not rotating. So E, so this is the source, one would think, yeah? So light, the position of E is measured with mirror R, not rotating. Now this is a mirror. Oh, is it rotating that way, or that way, or that way, or that way? Right? Thus, with R at right angles to the light rays from S, thus, with R, so R, the mirror, is at right angles to S. Is it? Is that a right angle? Sure, it was 90 degrees for a right angle. Anyway, doesn't matter. Look, from S, the rays are returned towards S. And some of, I did try to rush this, I'm not really, I didn't, it's very unprofessional, I know, I did not read, I didn't prove it, or reflect it toward S, and some of them are reflected to E by the half silvered mirror G. So some of the rays are returned towards S, they bounce off because it's at an obvious right angle, bounces back to S, and some of them are reflected to E by the half silvered mirror G. So some of them go back, and some of them go to there, bang, down to E, okay? That's interesting. The position of E is measured with mirror R not rotating. Thus, with R at right angles to the light rays from S, the rays are returned towards S and some of them are reflected to E by the half-silvered mirror. Boom, 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 half-silvered mirror, E, right? On the other hand, E1 is measured with mirror R rotating. Right, so do they do it twice? One without the mirror rotating, just, yeah, okay, the light goes there, and then they say, okay, well, let's go for the other one, and they start, and then, as it's rotating, on the other hand, E1 is measured with the mirror R rotating. The rays from S to position 1 of mirror R, but like I said earlier, there is no 1, 2, B, C, it's just R. R, rotating mirror. So again, straight away, if you wanted to recreate this, you're lost when it says this. The method depends on the relative position of points E and E1. Okay, so we can't do it. The rays from S to position 1 of mirror R. They are reflected to mirror, oh sorry, so, right. On the other hand, E1 is measured with mirror R rotating. The rays from S to position 1 of mirror R, there is no position, it's just mirror R, right? They are reflected to mirror M, right, which returns the light to R. Because of the time required for the light to propagate from R to M and back again, R moves slightly away from position 1. Okay, so I'm trying to do it bit by bit. Let's do that again. On the other hand, E1 is measured with mirror R rotating. The rays from S to position 1 of mirror R, they are reflected to mirror M, which returns the light to R. Because of the time required for the light to propagate from R to M and M and back again, R moves slightly away from position 1. So the mirror moves slightly away from position 1, causing the rays to be returned to G, which is the half-silvered mirror, along a slightly different path. So what we have is, right, but that's lens. And has it once, right, said anything about the lens? It's not even mentioned, is it? I just noticed that myself. Well, I know it's an absurdity, so it's like writing a play, a Disneyland play from Mickey Mouse and Donald Duck or something, so I don't really, because it's just blah, blah, blah. It means nothing. Oh, God, a slightly different path. This in turn causes, look, I apologise, all right? This is what happens. I'm supposed to be having a nerve war with 3 teenagers right now, so I apologise for this rush. Causes, right? So we've got an extra causes. So if anybody's missing one or needs a causes, just take that one. Causing the rays to be returned to G along a slightly different path. This in turn causes E1 to be slightly displaced from E. Now, is this a blank piece of paper? Is it a 1 meter square block of something painted black so that we can see the light returning? What is E? What is E1? Right? By measuring the amount of displacement and by relating it to the distance from R to M and from R to G and to the rotation rate of R, right? Because we all know what that is. The travel time and thus the speed of light can be calculated. And then I wrote bollocks after all of that, because that's what it is. Now, at times I've said there is not one logical working out of the speed of light anywhere. This is what I mean. One number. Why is there not one number? Why have they not said, right, if we stand, or if we have a mirror, a source and a mirror 10 meters away, with a lens at 4 meters from the source and 6 meters from the fixed/rotating mirror. And then we have another mirror that's 6 meters. Why is there not one single number? If this is the way that the speed of light is calculated, why have they not put numbers to show us exactly the breakdown so we know how it's worked out? And this is what I mean by you will not find one single working out of the speed of light with the numbers to go with it. Why? Because that's that bottom word, see? Right? Just reading this, it drives me nuts that people, they read this stuff, right? And they think they understand the science. This is the worrying bit. But he used mirrors, they screamed, a beam of light. In the early 1800s, when there was no power, what kind of a beam of light? It just goes on and on. Römer, Bradley, Fizeau, there's all of these, just no, it did not happen. No, it did not happen. No, it did not happen. And it's so obvious. Like the Egyptians not building the pyramids. It's so obvious. So what is it with everyone that I just don't get it. I just don't understand it. It's like people are being trained to ignore facts. This is an absurdity, right? This. How anybody could look at this, right, and read that and think it means something is amazing, because it doesn't mean jack. It doesn't mean jack. Is it 10 kilometers, a meter, 3 meters? And this is the typical 19th century method for working the speed of light out. And again, I'm going to say it right. So why not give us the numbers to see what distances, how many rotations per minute, per second? I mean, and Römer's the same, Fizeau's the same, Bradley, well, Wheatstone. If you look at these things, and you look at them objectively, right, you'll go, no. No, he didn't. And think about the other one, Bradley, and you'll go, if you're objective and you use the facts, right, and you'll get all the way down to Michelson. Because I think it was in the first one he did was in 1879. I think I mentioned this before. Alexa, when was electricity first used in the US of A?
According to an Alexa Answers contributor, electricity was first available in the United States in the year 1882. American inventor Thomas Edison helped form the Edison Electric Illuminating Company of New York, which brought...
All right, Alexa, stop, thank you. Alexa, stop! So, but Michelson, his first one, I believe, was in 1879. So, naked flame. How? Mirrors. What is it that people can't see about this, right? All of them. You have to be objective. You have to look at these things objectively. Right. So I went out today, got some new ones. So if you don't mind, I will be back with pyramids tomorrow, unless there is another reason to come. I just don't want to come back to this light thing. Light radiating from the sun, it's absolute. You will not see it. You cannot measure it. It's beyond measuring. It's beyond all of that stuff. Well beyond it. Because if all those books were planets, or let's say this one is Pluto. So that's Pluto, yeah? See it? And there's planets here, look! I don't know. Jupiter, yeah? Oh, whatever. They're all planets. If the sun turned off and was behind everyone, right? And that one is Pluto. Oh yeah, you can see them. But then, look, all the planets, right? Furthest away is Pluto. This is what would happen. Oh damn, the sun's going off. Oh no, oh it's ever so cold. Somebody! And then somebody hit the switch. This is what would happen. Boom! And Pluto would be illuminated immediately. Because the light from the sun is absolute. It's a slam dunk. It's as much about diameters as it is about looking at it in the sky and feeling the heat coming off of it. Anyway, but that's not chess. I'll be back.